So when we're talking about probability experiments, we're talking about ways that certain things that we call events can happen where the likelihood of those things happening is not guaranteed. It follows from some amount of randomness, although sometimes we can take probability experiments with guaranteed events, but well, those aren't very interesting, are they? And with those events, we can talk about them being simple, where an event is simple if it can only happen in one way. And when you're talking about simple things, it's easy to sort of visualize that idea in terms of a coin flip, where there's only one way that I can flip the coin like I just did and land tails. So it makes sense that the event landing tails is simple. But you can make it a bit more general than that. For example, I can talk about the probability of getting an event of tails, and if I take a deck of cards and just draw a card from this deck at random, the probability that the card I draw is the ace of spades. That is, the event here is ace of spades and tails, where what's important to note is that even though two things are happening, there's still only one way for both to occur. On the other hand, if I take my deck of cards again and instead talk about getting the tails and getting an ace, well, the ace of spades is an option to go with the tail. So is the ace of hearts, the ace of clubs, and the ace of diamonds. So in that case, we would not have just the one option anymore. We would have four. And that's the distinction between a simple event and an event that is not simple, whether or not you have a single way to get it. And to better understand this, we're going to look at a couple of examples. So for our first example, we have that for quality control, you randomly select a machine part from a batch that has been manufactured that day. Event A is selecting a specific defective machine part, where we ask the question, is this event simple? Well, our answer here depends on whether or not this can happen in multiple ways. And here, we're just looking at whether or not we can get a single specific part that is defective. Presumably, there's only one way to get the single defective part. So, this event would be a simple event. On the other hand, let's say that you roll a six-sided die, and we have event B is rolling at most a 4, where here we want to determine if that event would be simple. And what we need to understand is that with our die, yes, rolling a 4 is a simple event, but the problem is we could also roll a 3, a 2, or a 1, and any of those options would still satisfy what we're looking for. Any of those options would be equally good for at most a 4. So, because at most 4 is 4, 3, 2, or 1, there's 4 ways that that event can happen. So it is not simple. And I'll say now that when it comes to our problems, even though I said it's not all about gambling, gambling's an easy place to mine examples from. And it will do you a lot of good to understand that when we're talking about die, usually we'll specify the number, but if we don't specify the number of options we have, it's probably going to be 6. And when we're talking about those decks of cards, it always surprises me how many students aren't familiar with a basic deck of playing cards, but it's important you learn the fundamental patterns there, like that there are 52 total cards split into 4 suits with 13 cards each. But anyway, that's the idea for a experiment and an event in probability. We'll see a lot more with this, but next we're going to look at how we can count out our number of options for an event, because well, not everything is simple, and we've already seen that it's pretty easy to make large groups of events from small amounts of selections. So we're going to use what's called the fundamental counting principle to build a general pattern for describing that type of thing.